Hello everyone, welcome again to another interesting short tutorials of solar power system installations. Just as you all are aware, just as you all know, we make these short tutorials on solar power system installations to create awareness, to educate you all, to also keep you informed. It doesn't really matter where you're coming from, whether you are a technical person, whether you're an electrical engineer, whether you're a professional in the field, whether you are a beginner, or even a client who wishes to have basic knowledge and understand how or the working principle of his or her solar system. Yes, I am Chukuma Madukwe, the training director of Field Tech. Today's topic is a very interesting one. It is the one we call the technical parameters of a solar panel. These technical parameters of a solar panel has always been a challenge, a problem, creating confusion, not just for professionals in the field, but for those who are just coming into this field. Even clients at times calling to ask, what are these parameters that we are talking about? And today we have decided to make this short tutorial or to include it in our short tutorial videos. So you are all going to be informed from this. Yes, so technical parameters as we have it are or is one of the key things you need to take care of when it comes to solar power system installations. Yes, it is the key thing or one of the key things you need to take care of. Okay, so when we talk about the technical parameters, it is actually going to point you to a direction. It is one of the things that will help you detect fault in your systems and also show you a pathway to solving that problems or fault. So relax, sit back, grab a popcorn and roll with us. So the very first thing we'll be talking about here is introducing you guys and reminding you of what a solar panel is. Since we're talking about technical parameters of a solar panel, it is worthy to remind you what a solar panel is. A solar panel or a photovoltaic panel is a device that converts sunlight into electricity. What that simply means is that solar panel is one of the solar system components which absorbs the rays of the sun and convert it to electricity for you to be able to use in your facility. These solar panels are made up of photovoltaic cells that are silicon-like materials. Okay, so you might not need to worry yourself about the technicalities involved in manufacturing these solar panels because this is not what this that's not the aim of this short tutorial. Okay, it is not the aim. The aim is to expose you to the technical parameters of the solar panel, what makes up the solar panel, and not the manufacturing process. So talking about the photovoltaic cells is good. However, we are not going to give you the in-depth knowledge of these photovoltaic cells manufacturing. Okay, yeah. So moving ahead, we would also like to introduce you to photovoltaic terminologies. These are the terms and terminologies that you will be using, technical terms you will be using or you must have come across in this field of solar system installations. Yes, so even as a client, your installer or your technician might want to use these technical parameters to confuse you. Please, after going through this video, try to stand your ground to make sure that you are not cheated on your own project. So we have basically three terminologies that are very important in this field. We have the one we call the solar cell. We have the one we call the solar panel. We also have the other term, solar array. What is the solar cell? The solar cell is the device that converts the rays of the sunlight directly into electricity for you using the photovoltaic effect. So that simply means that your solar cell is the actual material or component which helps you to absorb the rays of the sun and convert it to electricity for you. So it is a solar cell. It is a single unit of your solar panel. I think that is the best way you can have it or you can put it. It is a single unit or the simplest unit of your solar panel that helps you to absorb the rays of the sun and convert it to electricity for you to use in your facility. That is the solar cell. Now, you have the other one we call the solar panel. The solar panel, just as you can see on my screen, is a group of cells assembled together. So your solar panel is made up of a group of cells that are assembled together, which means if you combine different cells together, different photovoltaic cells together, you are going to be making your solar panels yourself. So it means that in your single solar panel uh, component, there are specific number of cells that make up that your solar panel. So it means when your technician who is handling your solar system tells you that the panel he bought has 60 cells and that is what makes it 300 watts, you should be able to stand your ground because you have done your own research to say that a 300-watt solar panel is made up of 72 cells. Yes, I think that is a better argument and that is a more realistic argument because you already know what your solar cell is and you already know what makes up your solar panel. Your solar cells makes up your solar panels and your 200 watt, your 300 watt, your 400 watt solar panel, they all are made up of these solar cells. However, your solar panels should have nothing less than 60 to 70 to 72 solar cells, depending on the size of the solar panel. Okay, depending on the type of the solar panel and also depending on the manufacturer of that your solar panel. However, from your 200-watt solar panel upward, the least you should have or the least you can have depending on those parameters I listed out, depending on the type, depending on the manufacturer's specifications, and it ought to have about 60 to 72 cells. So that is enough information which should also guide you when you are also embarking on the journey of buying your solar panels. You know, dealers are very funny, they're very cunning. I wouldn't want to use the word fraudulent because we are all in this business together, all right? However, we are trying to expose you all to this thing so that you can uh, be more guided when you are making your choices. So we have the other term, the one we call the solar array. Just as you have it for the solar cell and the solar panel, the solar array is an assembly of various solar panels. That is to say, when you assemble your solar panels in series, parallel, or series parallel, that is what makes up your solar array. So a group of solar panels would help you to get what you call your solar array. Okay, and why do we have a solar array is very simple. Just as most of you who have already enrolled for our solar installation course, you find out that you need to generate a specific amount of energy, and then one solar panel might not be able to produce this energy for you. So you need to get other solar panels, combine them together, join them together to give you this expected energy capacity or energy generation capacity, so to say. So this next slide gives you a combination of the all the common terminologies. Is the photovoltaic cells, as the PV cell, the module, the panel, the array, and what have you. Now the big guy of the day begins here. Technical parameters. What are the technical parameters of a solar panel? This is the core focus of the day. Please, you need to pay attention here. Technical parameters of a solar panel or solar panels are the specifications that define their characteristics, operating conditions, and performance under standard test condition, which simply mean that Your technical parameters for a solar panel defines each and every of your solar panel. It tells you the makeup characteristics, how it's going to be operating, and its performance. That is, in terms of efficiency, in terms of effectiveness, how much energy can you be able to generate with that your solar panel. That is what these technical parameters would tell you, and this is considered under standard test conditions. We would talk about standard test conditions in a broader um, um, manner. However, to give you an insight to what we mean by standard test condition, it simply means that there is a, a situation, there is a room where these solar panels have been subjected to. So there are conditions which this your solar panels have been subjected to in the lab. Therefore, they can now be said to behave in a specific manner. So the technical parameters of your solar panels are usually shown by the nameplate of your solar panels. Yes, I believe by now those of you who have enrolled for our solar installation course, you must have you must be very familiar. In fact, you must be very familiar with what the nameplate is. However, we will show you what a nameplate is. So this is practically what a typical nameplate is. It shows you or covers all the details concerning your solar panel. Okay. Now, what are the solar cell parameters or the technical, your solar cell technical parameters? You have the one we call the short circuit current. We have open circuit voltage. We have maximum power point, voltage at maximum power point, VMP. We have current at maximum power point, IMP. We have the maximum series fuse rating. We have the Okay, so we have the maximum series fuse rating. We also have the fuel factor. We also have the efficiency. Relax, just like we said earlier, grab a popcorn. We are going to dive deeply into this and give you all the information as it concerns these your technical parameters. All right, so this is a typical picture of your technical parameters for a solar panel. You can see the fuel factor, you can see the short circuit current, open circuit voltage efficiency, maximum power point, voltage at maximum power point, and then your other parameters. Now, short circuit current, ISC. Short circuit current, ISC of a solar panel is that current or the maximum current which your solar panel can produce at no load. This simply means that this is the current that your solar panel can produce when it is not loaded, when it is at rest, when you have not connected it to any other solar panel or connected it to the load. That is either the inverter or the charge controller, depending on the type of connection you intend to make. This your short circuit current signifies the actual current of that your current rating of that your solar panel, due to the fact that it is the current which you will be getting when the solar panels are not connected to any load at all. I hope it is very clear. So before an installation, it is usually advised that you take the current ratings of your solar panels so as to be guided and to know the performance of that your solar panel. So early in the morning, before you install your solar panels on the roof, what you need to do is you take your readings, your measurement by measuring with your multimeter. So you should get the rating of that your current of this that is stated by the manufacturer on the nameplate of that your specific solar panel that you're working on. But you might ask, what if the ISC you get is not up to what is written on the nameplate? Is there a cause for alarm? No, there is no cause for alarm at all. There is no cause for alarm. What you need to know and understand is that um, due to the fact that it might be early morning when you are about to start the installation and you're taking this reading, it might be that the solar panel has not fully woken up. And as such, it might not be in a good mood, in a good shape to give you that full or complete uh, ISC that is required. So what do? You put it aside, put it where it can get enough air, put it where it can get enough sunlight, that early morning sunlight. Once it is heated up a little bit, take the measurement again, you will see it bounce back to life. Now you have the open circuit voltage, just as the short circuit current. The open circuit voltage is the voltage that your solar panels produces when it's even it is at no load. That is to say, when it is connected to no load, when there is no load connected to it under standard test condition. And every other discussion that has happened in ISC, it's also happening here. You might not actually get it when you take the measurement because it is early, so you troubleshoot the same way you troubleshooted for the ISC. Now, this is quite different. Voltage at maximum power point. This voltage at maximum power point is the voltage of the solar panel, the voltage that the solar panel produces when it is operating at full load. Yes, when the solar panel is operating at full load. So what this simply means is that this is the voltage the solar panel produces at full load when operating at maximum power under standard condition. It means in another way that it is the voltage that you will get if you take your measurement when you have connected your solar panels together, when you have connected your solar panels to the load, when you have mounted your solar panels and connected it to your load, either your charge controller or directly to your inverter. Your VMP, which is your voltage at maximum power point, is always less than your open circuit voltage. Yes, so it is less than the open circuit voltage due to the fact that it has been connected to other solar panels or it is operating at full load. All right, and it is this voltage at maximum power point that specifies or that guides you to how you can be able to connect your solar panels. Yes, to either your charge controller or your inverter system. So what that simply means that this your VMP guides you properly as to know how or the kind of connection method you will be using, you will employ when you want to connect your solar panels together, either in series, either in parallel or in series parallel. So this VMP will inform you of how you can do that connection depending on the parameters of your other working components, such as your inverter or your charge controller. So that is the much information we can give you on this VMP. There are so many technicalities involved in it when it gets to the real life situation, and that information is strictly reserved for our trainees. Okay, so you can get more insight on that. However, you need to enroll fully for our solar system installation course. We have the current at maximum power point. What is the current at maximum power point? The current at maximum power point is the maximum current the solar panel produces at full load when operating at maximum power still under standard condition. Do not forget, all these things are done under standard condition. There are conditions, there are factors, there are scenarios which guides your parameters of the solar panels. Okay, and just as we talked about the VMP, the IMP is also less than the ISC because it is the current that we get when the solar panel is working at full load. So we also have the maximum power point, which is the Pmax. Yes, we have the maximum power point, which is the Pmax. Now, the maximum power point tells you the actual wattages of your solar panel. And as you can see on my screen, it is telling you that it is the maximum wattage of power a solar panel can output or produce under standard test condition. So the maximum power point tells you the actual wattage of that your solar panel. That is, it tells you the capacity of that your single solar panel. That is what the maximum power point tells you. Now, the maximum power point is a function of VMP and IMP, which simply means that if you want to get your size of your solar panel, you need to just multiply your VMP and your IMP together in order for it to get that. So this is a bonus information. In cases of troubleshooting, if you are an engineer, if you're a technician, and you are in the field, in cases of troubleshooting when a solar system is malfunctioning, but you do not know, you are suspecting it might be solar panel, but you do not know, and then you needed to confirm the size of the solar panel. What you need to do, yes, what you need to do is you get the voltage that is being produced by the solar panel and multiply it by the current that is being produced by the solar panel. You can get these details from either your charge controller or your inverter system, depending on the type of system that you are actually running. So either of them can lead you aright, and you will get the size of the single solar panel, and then you will then know how many of it that is up in the roof and see if it is enough to power up that your facility. Like I said, that is a bonus information, okay, because you have the privilege of being here with us. So here is what we call the IV curve. This IV curve typically shows you or showcases um, all the technical parameters we have mentioned, okay? Showcases all the technical parameters we have mentioned. You can see the VOC being higher than the VMP and the ISC being higher than the IMP. You can see the Pmax being the meeting point between your IMP and your VMP. And just as we rightly said, your Pmax is a function of IMP and VMP, just as it has been illustrated by this IV curve. So this is another one that gives you a broader knowledge of that same IV curve. So moving ahead, you have the technical parameter we call the maximum series fuse rating. This maximum series fuse rating specifies the highest current that its panel's internal components, such as wiring, can safely withstand in the event of a fault. This simply means that in terms of safety, if you have considered using fuses or fusing your solar panels, this technical parameter, maximum series fuse rating, tells you the actual size of fuses that will be used for each series or a series fusing for your solar panel. Yes, you must be very smart about this. You must know what you are also doing here right now, because for you to fuse your panels, it means that you already know what you are actually doing and what you want. So that is on the aspect of safety. And like we usually give it to those of our trainees who are already running these courses with us. If you also want to have a better knowledge of how you can fuse your solar panels in terms of safety, please do not hesitate to enroll for our solar installation course fully. Now you have the one we call the fill factor. The fill factor is a measure of the quality, the performance and efficiency of your solar panel. So this simply means that the fill factor actually tells you the quality, performance, and efficiency of your solar panel. That is what the fill factor tells you. The fill factor is a ratio of VMP IMP to VOC ISC and ranges from 0 to 1, which means if we do a system design concerning the solar panel and we consider the fill factor, after we design for the fill factor and we got a, a value of 1, it means that the efficiency of this solar panel is top notch. The performance of this solar panel is top best, and the quality is also something to write home about. That is what this fill factor tells you. You can see a diagram showing you the fill factor, right? Yeah, you can see a diagram showing you the fill factor, and just as we stated it out clearly, the fill factor is a function, a ratio of IMP, VMP, and ISC, VOC. Now, the efficiency of your solar panel. The efficiency of a solar panel tells you how effectively a solar panel can convert your sunlight into electrical energy under standard test condition. What this efficiency of your solar panel tells you is practically or typically informing you that or telling you how much energy can your solar panel convert for you, how much of these rays of the sun can your solar panels convert for you and generate for you. So if your solar panel generates a whole lot of energy for you, you call it an efficient solar panel. So solar panel is a ratio of output power to the input power of the panel and ranges between 20 to 23%, which means, again, if we do a proper system design for your solar panel, considering the efficiency of the solar panel, and we have a value of 23%, it means that that is a very good solar panel. Now, let's talk about this standard test condition. So, the standard test conditions of a solar panel typically tells you the set of conditions used to measure and compare the performance and efficiency of the solar panels in the lab. So now we have been talking about standard test conditions all this while. Yes. So what that simply mean is that these are the set out rules, set out conditions, set out parameters that are used to manufacture these solar panels in the lab. That is what it simply means. These are the various rules, conditions, or technicalities involved in setting up your solar panels in the lab, and these are the standard test conditions. So basically there are various standard test conditions, but out of everything, two are the most important, and that is why we have decided to consider it here right now. Okay, we have decided to consider it here right now. So we have the irradiance, which is put at standard test condition to be 1000 watts per meter square. That is the irradiance, 1000 watts per meter square, and the temperature, which is also put at 25 degrees centigrade, which is equivalent to 77 degrees Fahrenheit. All right. So now the temperature, talking about the temperature a little bit, what you should know and understand when it comes to the temperature is that as this is the temperature that has been stipulated as standard test condition, 25 degrees, it means that your solar panels would function perfectly. The efficiency of these solar panels would be top notch, would be maximized as long as the temperature of your solar panels do not exceed 25 degrees centigrade, in as much as there is still a little bit of tolerance when we talk about these temperatures, right? Yes, but however, it should not be too high above 25 degrees centigrade. it is going to cause issues for you. So it means that when you are having challenges with your solar system, your charge controllers are having issues, they are not charging the batteries when the sun is at its peak. What you need to consider is, how is that your solar panel installed? And that brings us to another interesting troubleshooting knowledge we want to give out to you guys for free. Now, one of the basic reasons why you are asked to use solar accessories in terms of the solar rails when you are installing your solar panels on the roof, you are advised never to install your solar panels directly on the roof. On no account should you install your solar panels directly on the roof. This is to allow for cooling of your solar panels. Remember that your solar panels are going to be on the roof. When the sun is at its peak, your solar panels are absorbing the rays of the sun. At the same time, your roof is also absorbing some of the rays of the sun. So, if your solar panels are sitting directly on top of the roof, there is no allowance for air to go underneath the solar panel to cool it a bit. It means the solar panel is absorbing uh, heat from the top and it's also absorbing it from under. It is going to make it to malfunction. But when you use your solar accessories such as your solar rails, you are going to have a wonderful solar system setup. Yes, that is just the truth. You are going to have a very wonderful solar system setup. So when your solar panels are having technical issues during the day, they do not charge, but the sun is out, sun is up, you should at least check to see how that your solar panel has been installed. So we are wrapping up. We are coming gradually to a close on this tutorial video. So factors affecting your ISC, your VOC, your PMAX, your VMP, your IMP, your fuel factor, and your efficiency. Irradiance, sunlight intensity is one of them. Yes. So just as you have seen it that at standard test condition, your irradiance is put at 1000 watts per meter square. It simply means that, give or take, below that, you will not have the efficiency of your solar panel work well. Above that, you might have your solar panels malfunction. That is true. In as much as you need enough sunlight for your solar panels to generate enough electricity for you. Yes, that is very, very correct. That is true. However, you also need to take into consideration that too much of it can also cause damage to your solar system and will affect this your technical parameters, especially your VMP and your IMP. So as a client, your take home from this tutorial video is the fact that your solar panels need enough sunlight for it to perform its duties. So when it is during the morning session, your solar panels can charge your batteries, very correct. However, it needs the sun to be at its hottest zone for it at its peak, for it to generate a lot of energy for you. So you should not crucify your installer or your technician or anyone who is managing that your system if your solar panels are not charging your batteries. So we thought it wise to include this here so that clients who are fond of running after individuals, technicians who are just trying to be the best in what they do, accusing them of this and that, can actually calm down because they have not committed any crime. Again, temperature. Temperature can actually affect your technical parameters. Yes, like we said previously, too much temperature, too high temperature can actually make your solar panels malfunction, and in such cases will not produce that required amount of energy for you. Shading is another type of factor which will in fact drastically kill the performance of your solar panel, and the efficiency of your solar panel will bring it down to zero. Now, in solar system installations, when you go for site survey, you are also to consider the place of installation for your solar panels. And at no point in time should you install your solar panels under a tree or where you are having shades over it, or where a taller building that will cast shadow on those your solar panels will be placed. On no account should that ever happen, because once a side of the solar panel is shaded, the efficiency of that solar panel has been reduced. Even though you might be using a super solar panel like your bifacial solar panel or your half-cut solar panels. However, you are still advised not to cause shading to your solar panel. Now, the solar panel size, yes. Now, we have found out over the years with our experience in the field that some installers who are encouraged by some clients, they do this funny thing, use a small size of solar panel. They want to use it to power up a facility or recharge a battery. Let's take, for instance, 200-watt solar panel, trying to use it to power up your trying to use your 200-watt solar panel to power up your 5 kilowatt hour lithium battery. That is almost impossible and not advisable for anyone to do. It's not advisable for anyone to do. So you are kindly advised not to do that. Angle of incidence. Angle of incidence and angle of tilt are two similar parameters or factors that affect your the performance of your solar panel in terms of the technical parameters. While your angle of incidence talks about the actual angles, angle 90, angle 45, your tilt angle tells you your geographical hemisphere where you are located. Are you located in the southern hemisphere or the northern hemisphere? All right. As a rule of thumb, it is said and proven that if you live in the south, your uh, panel should face the north, and if you live in the north, your panel should face the south. And then you now talk about the angle of incidence. It should then be 90 degrees south or 45-degree north, whichever one. It all depends on what you have on ground. Then depth. There is a dirty solar panel can reduce the performance of that your solar panel. Age or longevity. That simply tells you that as the day goes by, as you are using your solar panels, it will also be reducing in terms of the age. Now, wrong cabling or wiring. When you have wired your cables wrongly, when you have wired your cables um, wrongly, or when you have wired your panels wrongly, you are going to have this your uh, solar panels perform poorly. Okay, they're going to perform very, very, very poorly. In another term, to put it clearly, if it's a situation where you're supposed to wire your solar panels in series and you did a parallel connection, you would have a poor performance of your solar panels, and your VMP and your IMP will be greatly affected. Yes, we are gradually coming to an end of this tutorial video. So once again, this is a similar solar panel nameplate that we showed earlier. From the model number PPS 150 watt, it is shown that this is actually a 150 watt solar panel. And the other things here you can see on my screen are the parameters of this 150 watt solar panel. You can see the maximum power Pmax to be 150 watt. And the good thing about the solar panel is that you have also been given tolerance, which is 3 watts, which means this solar panel can produce up to 153 watts, and when it's performing at its peak, it can even give you 160 watts. You can see the VOC and the VMP, and clearly the VMP is less than the VOC, just as we have discussed earlier. The same applies to the IMP and the ISC. You can also see the fuse rating maximum series fuse rating to be 15 amps. In some solar panels, the manufacturers can specify it to be 20 amps. Please make sure you use 20 amps fuse while you are wiring up your solar panels. You can also see the other standard test conditions, the irradiance 1000 watt per meter square, and your temperature to be 25 degrees centigrade, which means if this solar panel is heated up to say 40 degrees, you will have issues in this your solar panel. All right, so just as we said, we have been able to walk you through the process of getting to familiarize to understand the technical parameters of your solar panel. We hope we have been able to impact knowledge as we always do. For us here in VatFuel Tech, it is a privilege to impact knowledge. For questions, for observations, for every other thing, please do not hesitate to reach out to us, either via our WhatsApp or our social media handles or email. We are always available. If you want to enroll for any of our courses, solar system, CCTV, automation, automatic changeover, anything you want to enroll for, we are open, and enrollment is currently ongoing. It is I, your favorite solar guy, Chukuma Marupe. See you all in the next tutorial video. Bye bye.